Hello, my dear students. I am Sadashiva Belikatti and I have completed MSc in General Chemistry with B.Ed and qualified Karnataka TET in the year 2015. My dear students, in today's class, I am going to begin with the new topic of this second PUC. First unit is solid state. Dear students, do you know the name matter? Yes, absolutely, you know. Why? Because the universe is made up of matter, isn't it? And now define what is matter. Matter is a substance which has definite shape, size, and volume. It occupies space. Also, it has mass. And when we come and examine this matter, we found three states of matter. How many? Three states of matter. These three states of matter mainly are solids, liquids, and gases. Solid state, liquid state, and gaseous state. These three states of matter lie under two important factors. They are, first one is intermolecular forces, second one is thermal energy. Intermolecular forces is always connect molecules each other, and the thermal energy keeps molecules away from each other because it changes the states of matter. When we heated the solid, it eagerly changes its state from solid to liquid, and when we heated that liquid, it converted in the form of vapor. However, the states of matter changes from one state to another state. There will be loose in the arrangement of molecules. Due to the losing of the shape, the size, the volume, the three states of the matters are formed. Understood? Dear students, you know very well, even after having a high effect of heat, the intermolecular forces plays dominance over the thermal energy. Why it happens so? Let me to explain with an example. See, I will draw a solid state. Just imagine it as a solid. Inside this, one minute. Just okay. Look at this one. See, just consider it as a solid. See how the molecular arrangement is there. There is a compact arrangement of molecules. I left here at least space, but in a solids there is a compact arrangement without intercellular forces, intercellular spaces, without intercellular spaces. Yes, my dear students. Now, just imagine it as a solid. Why it is called as a solid? Because there is a intermolecular force acting between each molecule. The strong force of attraction between each molecule holded each other and formed a thick solid. When the heat is applied to this body, it loses its shape. Just it changes its state from solid to, this one is solid, like a liquid. It converted in the form of liquid. While changing from solid to liquid, it changes only its state but not the intermolecular force. Not the intermolecular force of attraction. Intermolecular force of attraction. Hence, this intermolecular force, what it does? Predominate over thermal energy. This is one of the best point you should keep in your mind. Now, dear students, we shall discuss about the general characteristics of solids. Basically, what are solids? And what are the general characteristics of solids? We shall see here. General characteristics of solids. First point. Between the molecules, presence of strong intermolecular force. Intermolecular force. Second thing, short intermolecular distance, very short intermolecular distances. See here, between the molecules, presence of strong intermolecular force and very short, one more point, one more thing I had left here, very short, yes, very short intermolecular distances, very short intermolecular distances. Then the constituent particles fixed for a position, fixed at a position, they could not change their position. Why they changed their could not they change their position? Because see here, this is the arrangement of solids, this is the arrangement of molecules or particles in the solids. Due to this reason, these particles can't move freely. For that reason, they had fixed position, they had fixed position. Okay, next go for the see here, the vibrational motion, the vibrational motion of a constituent particles the vibrational motion of the constituent particles undergo about their mean position. The vibration of the constituent particles undergo about their mean position. Next point is solids have definite size, shape and also what? Mass. And the solids have rigidity, they have rigidity, incompressibility, and high density. My dear students, I will explain one by one each character. If you consider a solid, there is a strong, okay. My dear students, if you consider a solid, there is a strong intermolecular force held between the molecules. First point. Second point, they have fixed position. Third point, they vibrate at their mean position. Fourth point, they have definite shape, size, and mass. Fifth point, they have toughness. They have incompressibility, means they do not change their size. And one more point added to this one is they have high density. High density means what? Large number of molecules present in a small area. That is high density. The next, after discussing the general characteristics of solids, we shall move further for the classification of solids. Classification of solids based on the arrangement of orderly arrangement, not a single arrangement, that is orderly arrangement of constituent particles in 3 dimensions. The solids have been classified into 2 types. Solids have been classified into 2 types. What are those 2 types? First one is crystalline solid, second one is amorphous solid. I will explain these theories, that is crystalline solid and that is amorphous solid. After the completion of this explanation, you can compare those 2 things yourself and write down in your book. Okay. Dear students, in a crystalline solid, I will write the headline also, classification of solids. First one is crystalline solid. What are crystalline solid? First thing is orderly arrangement of constituent particles. Orderly arrangement of particles. Orderly arrangement of particles in 3 dimensions. Second point is they possess both short order and long order. They possess both short order and long range order. What do you mean by short order and long range order? It means the constituent particles repetition is regular and periodic. It means the repetition of constituent particles over the entire crystal is regular and periodic. Regular means serial, continuous arrangement. Periodic means Here one white, one black, one white, one black means periodic, alternate. Alternate. This one is continuous. I think you got my point. Here in the crystalline, the constituent particles are arranged or repeated, and the repetition of the constituent particles in entire crystal is periodic and regular. It means they possess both short order and long order. Okay, now let me to explain the third general characteristics of crystalline solid. They have sharp melting point. They have sharp melting points. My dear students, see here, they have sharp melting point means accuracy in the melting points. There will be no falling above the melting points and falling below the melting points. Accuracy, maintenance of accuracy in the melting points. And next, they are anisotropic. They are anisotropic. It means some of the physical properties such as conductivity and refractivity index, etc., have different values when measured along different directions. See, anisotropic means what? Anisotropic means what? The physical properties such as conductivity, refractivity index, etc., have a different values when measured along different directions. In whatever the direction you may measure, the refractive index and the conductivity, they are vary and they are different. I think you understood my point. Next, they generate smooth and plain new surfaces when cut with sharp edged tool. My dear students, look at the thing. They generate smooth and plain new surfaces when cut with sharp edged tool. Whatever the tool you may take, if it has a sharp edged tool, and if you cut with that, they generate smooth and plain new surfaces. Then they have definite values for enthalpy of fission. They have definite values for enthalpy of fusion. One more thing, these are true solids. These are true solids. The best example for these, sodium chloride, quartz, cesium chloride, copper, zinc, etc. And the structure of this crystalline solid is likely to be benzene, but not benzene. It looks like benzene, but not benzene. It has sharp edges. Remember the thing. Yes, structure. There is a order arrangement between the molecules. Yes, understood. Similarly, the amorphous solids are also classified here, and the general characteristics of amorphous are, we shall see here. In the crystalline solid, there is a regular arrangement, but here in amorphous solids, what happens? They have irregular shape. First one is irregular shape. Second thing is they possess only short range order. It means here, especially in the amorphous solids, the regular periodic repetition of constituent particles is observed over short distance. It can be observed short distance. Regular and the periodic repetition of constituent particles can be observed under short distance, means they have short range order. Next, go for third point. They melt gradually over temperature range. They melt gradually over certain temperature range. They start to melt. They are isotropic. They are isotrophic. Isotropic means what? In whatever the direction you may go and measure, the refractive index and this conductivity physical properties are shows the same values. There in the crystalline solids, it is different. The physical property shows different values for different measuring directions. But here in the isotropic amorphous solids, it shows same values for different kinds of measurements. When cut with sharp-edged tool, irregular surfaces are generated. They generate irregular, they generate, 1 minute, instead of writing all these, because one space makes different meanings. They generate irregular shapes even on cutting with sharp-edged tools. They do not have definite values of enthalpy of fusion. They do not have definite enthalpy of fusion. They do not have definite values, definite values. Here add one word, definite values for enthalpy of fusion. Definite values for enthalpy of fusion. Yes. Next, they are pseudo-solids or supercooled liquids. They are pseudo-solids or supercooled liquids. What is this new character, pseudo-solids? Pseudo-solid means it neither lie between the true solid and true liquid. Pseudo-solids means it has amorphous character, but it does not reach crystallinity and it does not reach the liquidity. For that reason, these solids are called as pseudo-solids and also called as supercooled liquids. And examples, glass, plastic, sulfur, starch, rubber, etc. And shape of and geometry of this solid is it is not as particular as I shown, just it is an assumption. Amorphous solids looks like this. Yes. Okay. Now I am going to explain one note for your knowledge regarding this. First note is, remember, The first note is the old window glasses or the window glasses of old buildings show milky. It is due to because of the partial crystallization of glass as a result of annealing. How it happens? If you have constructed a building 25 years ago, what happens? After 25 years, the window glass turned into milky due to the partial crystallization. That partial crystallization is due to the annealing effect. What is annealing effect? Heating during daytime and cooling in the night time. Similarly, the glasses of old building, the window glasses of old building, after some years, they melt gradually. They melt gradually and show thickness at the bottom and thin at the top. Why this is? Because of the amorphous character of solids. Amorphous character of solids. It is also called as the supercooled liquid nature or pseudo solid nature. Supercooled liquid nature or pseudo solid nature. Understood my point? Yes. Dear students, these are all the very important thing, and in a crystalline solid, it is due to the orderly arrangement of the particles which are present in the crystalline solid. Next, we have discussed till now regarding the solids into crystalline and amorphous solid. Now we are going to convert or explain the classification of this crystalline solid. Crystalline solid further classified into 4 important types. First one is crystalline solid. Under this first one, that is ionic solid. First thing in this is ions are constituent particles. Ions are constituent particles. Okay. They held together by strong electrostatic force of attraction, strong electrostatic force of attraction, isn't it? In ionic solid, there is I already told you regarding this one. It is due to the strong electrostatic force of attraction. that is ionic bond. Then these have high melting point, high melting point and boiling points. Also brittle, sorry, 1 minute, there is a spelling mistake. Brittle and what? Hard. Next, they conduct electricity. They conduct electricity in a in molten state, not in solid state. Dear students, look at this very important point. The ionic solids mainly conduct electricity in a molten state or in dissolved state, not in a solid state, because when the ionic solids are dissolved in water, they split into ions, and these ions having two charges, that is positive charges and negative charges. Because of the presence of charges on the ions, they start to conduct electricity. Example NaCl. Second point is zinc sulfide. Then MgO. MgO and cesium chloride are the best example for these ionic solids. Next, go for second one is covalent solids. Covalent solids. What are covalent solids? Covalent solids are, first one, the constituent particles in the covalent solids are nonmetals. Particles are nonmetals. First thing. Second point inside this covalent, these are called as giant molecules. These are called giant molecules. Next point, the covalent bonds are strong and directional. Strong and directional. Remember the thing. Next, go for they held strongly at lattice points. Next, due to the absence of charges or ions, these are insulators. These are insulators. Next, they are brittle. They are brittle, hard, and extreme high melting point. Extreme high point. But graphite is an exception. Graphite is an exception. Dear student, I will explain one upon one. See, the constituent particles of in the covalent solids, the constituent particles are non-metals, and these are called as joint molecules. The covalent bonds are strong and directional. They are strong and having definite directional, means they have certain directions, the bondings. Then they held strongly at lattice points, means at the sharp points. It might be lattice point, may be face or body, or it may be edge. And due to the absence of charges or free ions, these are act as insulators and they do not conduct the electricity. They are brittle, hard, and extreme high melting points. After observing all these, graphite shows an exception character, that is due to the presence of that is because the graphite is used in the cells as a electricity conductor. Graphite is used in a shells as a electricity conductor. Graphite, see, this graphite is allotrope of carbon. Allotrope of carbon. But comparing to the all allotropes, graphite has exceptional character because it conducts the electricity. Okay. Okay. Next example for this one is silicon, comma, graphite, comma, diamond and quartz. Diamond and quartz. Yes. These are some of the important examples. Yes. Now come to the next classification is metallic solids. What are metallic solids? Metallic solids are mainly formed. Here, the constituent particles are mainly metallic kernels. First point, they metallic kernels. They are good conductors of thermal and electricity. They are good conductors of thermal and electricity. Next, they have metallic bond between each metallic kernel, and they have variation in the bond as well as in their melting points. They have variation in the bonds as well as melting point. And some of the example for this metallic solids are, I will go and explain continuously this one. Third one is metallic solids. First one, constituent particles are positively charged metal kernels. I already told you regarding this one. Second thing is, there is metallic bond held between each molecule. Next one, there is variation in what? There is variation in melting point and bonds. Next, the very next point is, they are malleable and ductile. Due to presence of free and mobile electrons, due to the presence of free and mobile electrons, what happens? High electrical and thermal conductivity. Example, sodium, zinc, copper, brass and bronze. When force is applied on the body, they convert it into thin sheets. and when hammered the body, they converted in the form of wires. These two properties are called as malleability and ductility, and between each molecule there is a metallic bond held, and these constituent particles are positively charged metal kernels, and due to the presence of free and mobile electrons, free and mobile electrons, the high electrical and thermal conductivity exists, and there is a sodium, zinc, copper, brass and bronze are some example for this metallic solids. And the final point is, fourth one is molecular solid. Molecular solids. All molecular solids are soft, low melting point solids. These are soft, first point. Low melting point, low melting point solids. Second point, they may exist in liquid as well as gaseous state also. Next, they may exist in liquid as well as gaseous state also. Next, look at the thing. At room temperature and pressure is very important. Temperature and pressure is very important for this existence, and they are non-conductors of electricity. They are non-conductors of electricity. Dear students, after this, based on this character, the molecular solids are classified into, it is also classified into three types. First one is non-polar molecular solid. Non-polar molecular solid. What is the main characteristics of this non-polar molecular solid? The constituent particles are held together by weak London force. The constituent particles held together by strong constituent, sorry, I have to use weak constituent The constituent particles held together by weak London force. Sorry. I made a mistake. Held together by weak London force or dispersion force. Example, solid helium and ice. This one is solid helium and nitrogen. Nitrogen, no, non-polar. Solid helium and nitrogen. Nitrogen. Next, go for the second one is polar molecular solids. Polar molecular solids. They held together by dipole-dipole interaction. They held together by dipole interaction. What is dipole-dipole interaction? Dipole means two poles, that is positive pole and negative pole interaction takes place between these polar molecules. Okay, they interact. Okay. Next, example for this polar bond. Solid HCl, because H is plus, Cl is minus, and solid SO2. This one is +4 and this one is -4. Why? Because of the oxidation state of the sulfur is +4 and this one is -4 and forms the single oxygen needs only 2 electrons, but here 2 oxygen, so it needs 4 electron. For that reason, +4 -4 equal to 0. If there is a 0 and forms the stable compound, if there is a 0 valency or 0 oxidation state, then this compound is stable. And final point is hydrogen bonded molecular solids. Hydrogen bonded molecular solids. The bonding forces are strong hydrogen bonds between the bonding forces are strong hydrogen bonding between hydrogen and fluorine hydrogen and oxygen, sorry,